Welcome to Code Club. So what we're going to do is we're going to practice our code reading skills by reading some Go code. First of all, try and figure out what does the code say, and then try and work out why is it saying that, what's this code doing and why. We'll also be practicing our communication skills, right? Because unless we're geniuses, we won't be able to understand everything ourselves, so we'll need to ask other people for help. So talking about code and asking questions and answering them about code is also a skill set, isn't it? So that's partly what we're doing here. So the project we're looking at today it's part of a client for an AWS Serverless application. So there's this thing called the Serverless Application Model, or SAM, and I haven't used it, but you know, if you're familiar with this concept of serverless, where basically, you know, what you'll be deploying to the cloud is a function which the cloud will run for you, may be triggered by some event or on a schedule or something like that. So we have this facility, and there is a CLI tool for managing your serverless apps, the SAM client, and this is a project called Sam Local, which is, the idea of it is that you can test your serverless apps locally on your machine using Docker, I think, and it will be effectively as though you were running them on AWS, so you can try them out before you actually deploy them. This is from a guy called Antonio Troina. And I saw this the other day and thought the code looked interesting. So we won't go through the whole thing because there's kind of a lot of it, but there's a couple of interesting bits of the code which caught my eye, which might be worth looking at. So one thing I wanted to look at is this validate test code here. So one of the commands that this CLI has is to validate templates. So these are YAML templates full of metadata about your serverless app, and you know, this is effectively part of what we're generating as part of a serverless deploy. So here's the code for testing this stuff, and it looks quite interesting. And if you're familiar with Go tests, it looks a little bit different probably to what you're used to seeing. Tiago, have you seen this kind of code before?
No, actually I've seen the internet, like some people doing like that,
Yeah.
using functions to assert and do this kind of comparison, but
Yeah.
yeah, it's not common, I would say.
So there's a lot of different, you know, each language has its own popular testing library and frameworks. Go has its own built-in one with the testing library, as you know. And that leads to a kind of a standard way of doing Go tests using the built-in library. You know, you'd set up what you want to get back from calling the function. You call it with some inputs, and you look at what you actually got, and then you compare want and got to see if they're the same, and if not, you fail. And that's simple in principle, but sometimes working out what your want actually is could be an interesting challenge. Also, figuring out how to call the function in a test environment. So not making any real network calls, not doing any long-running things, not touching the disk, and so on. But basically that's the shape of tests, isn't it?
Yeah.
And there's another kind of paradigm of this, which you know, if you're familiar with TDD, test-driven development, there's also an evolution of it called BDD, or behavior-driven development. Now, since your tests should be testing behavior, I kind of figure all development is BDD, right? But it's very often, by giving a name to something, it doesn't mean this is something new and original that you didn't know about. It just means here's a convenient label for talking about this particular focus on things. And it's associated with a tool called Cucumber, which has a kind of a domain-specific language for describing tests or describing test stories. And it's something like, there's this kind of language where you say, we can see it here. So we can say with such and such an input, it should successfully do something, something, something. So it's this language of saying, given X, it should do this, do that. And sometimes this is sold as being sort of a no-code solution to testing. I think, all these no-code ideas are fundamentally fraudulent or futile. And it's the same with this, really. If you're genuinely expecting, hey, I'm going to be able to give this to some non-technical folks, like the business team, and say, just express your business expectations about the program in this non-computery language, and it will be an executable specification. That would be wonderful, but it never quite lives up to that promise. Nonetheless, some people like to express tests in this way, and I thought it might be fun to go through and see if we can figure out how that works. And solutions, this kind of thing is often described as a DSL, a domain-specific language, and some programming languages really suitable for developing DSLs, like Ruby, because its syntax is so fluid. You can write almost any kind of language you want, and it can be valid Ruby. Which is nice. Not so easy in Go, is it? It's hard enough to get Go code to compile at the best of times. If you're trying to write something which is not Go in Go, that's really difficult. And I know because I developed a sort of a mini DSL for the script library, which we saw last time. So it's always going to be a bit difficult to get this to read smoothly. Shall we start and just see, perhaps, Tiago, you'd like to start reading us through this, and we'll see what we think about it.
Sure. So it's creating the main package.
Yeah, it's interesting that we're in package main, isn't it?
Yeah. I think they are just using one package for everything.
Yeah.
The Terraform does it too. It used the same package for the module, for the resource, for the code and for the test. So it doesn't import the module as the user would be doing.
Right.
So, and it's importing a bunch of packages, the Go formation.
Yeah, I'm guessing that's the CloudFormation Go SDK, because at some point we're going to be driving CloudFormation with templates and things.
Okay. And then there is this from this identity on ONSI. I don't know if it's a person or a company, but there is this functions that I have this package that I have no idea what does yet.
Right. This Ginkgo, this is the BDD test library, which enables you to do things like describe context, it should, and then expect yada yada and stuff like that. Gotcha. Have you seen this kind of construction before?
Yeah. I'm not sure if that's the case, but it's not got removed when you're not using or calling. I don't know.
Well, this is actually called a dot import, and what that does is, as you might know, if you just import the library, then that's fine. You just refer to things in GoFormation as GoFormation dot something. But if you wanted to, you could give that package an alias name by putting it before the import path. You could name it to, GF or something, if it pains you to type that package name so much. And your IDE doesn't.
So I'm
complete it for
assuming
you.
the dot it's going to import the functions as you can call without using the package name.
Yeah, that's right. So what that effectively does is just says, I want to be able to refer to names in this package without using any prefix whatsoever, just as
Mm-hmm.
though they were in my package.
Mm-hmm. Yeah. Yeah,
Um,
I think it's cool, but it's kind of dangerous
yeah,
if you have like the two like methods, uh, two
I agree.
functions with the same name.
I understand why people do this, but I don't think it's a good idea, and ultimately I think it's going to bite you.
Mm-hmm.
One reason that you might do that is the package name is just ridiculously long or unwieldy, or it doesn't make sense
But
with.
why just create an alias and
Yeah, and that's not your fault. I mean, you
mm-hmm.
you as the author of this code, that's not your fault. That's on the package author, because what they should have done is they should have imported their own package in the tests, and they should have used their package prefix and their own names, and they would have seen that it's really inconvenient for people. But
Mm-hmm.
sometimes packages are out there which are like this, and I think some sensible alias is fine, but
Mm-hmm.
a dot import like this is both dangerous because you might have the same name in your package, right? It's perfectly reasonable. Suppose you had a function called describe or something, or context. Um, well, actually, I don't know what would happen if that was the case, but it wouldn't compile because the compiler would say
Yeah.
function already defined, no?
Yeah.
Or if you refer to it, I'm not sure. But the very fact that it's not obvious what's going to happen is a big
Mm-hmm.
red flag, isn't it? And also, if you don't happen to have seen that part of the code and you're just looking at this, well, where does this come from? Who knows?
Mm-hmm.
Of course, the reason they're doing it here is so that we don't have to write every time ginkgo.expect and ginkgo.it and ginkgo.context. So that's really saying, because I'm trying to be a DSL in Go, you need to do this .import hack. And that is kind of, Go often has a way of gently guiding you away from things which are a bad idea, doesn't it?
Mm-hmm.
When you start to find that something is awkward or inconvenient to do in Go, the first thing you do is go onto Twitter to complain that Go sucks, because it made it hard for you to do what you wanted to do. But then if you think about it a little more, you might think maybe the language designers are aware of this, and it's not just that they didn't think of it, they did think of it, and they said, we don't want to make this easy for people, because they shouldn't really be doing it.
Mm-hmm.
That happens a
Yeah.
lot. So, okay, so we understand that, so please continue.
So yeah, so it's declaring a variable that's not stored. I'm not sure if I understand var underscore.
Yeah, so we haven't had any functions yet, which is interesting, and in fact we won't have any. We're not defining any functions. All we're doing is we're declaring an unnamed variable, or whose name is the blank identifier underscore,
Okay.
and we're assigning it the value returned by this describe function, which takes a name and a func, and that can be another describe block, and so forth. So we're into something that's really non-Go like, aren't we?
Yeah,
Like
but why I should? How can I use the blank variable? Like, or I'm not going. What I'm saying, I'm not going to use the value that's being assigned.
yeah, what we're really saying here is we're not interested in the actual value returned here. We just want the side effect of executing this function.
Okay, gotcha.
And I don't think that's, it's not really very nice to write code like this, I think. But let's see if we can figure out what's happening.
So yeah, it calls again the describe function that receives string and another function, and then it creates a context um, that receives another string and a function, and then an array of YAMLs, and then it range on these inputs and call the context again for each YAML, which is like a string contained with including plus the file name.
Yeah. This
And
isn't totally
okay,
crazy,
so
is it? This starts to look like something that we might recognize, like a typical table-driven Go test. You know, we've got a slice of inputs. We're
yeah,
going to range over them. We're going to call our function with each of them, and then we're going to validate some expectations about the results.
yep. So basically, all this is just he has a bunch of CloudFormation templates. I'm assuming each of these files in the inputs is a CloudFormation template,
Yeah.
and it's opening. So what's basically doing is validating the syntax of the YAML file.
Yeah, I presume so. Now, it's not. It doesn't look like this is actually our code. This is using Go formation, isn't it? So maybe this is just a way of saying these test data templates, which I'm going to use, these are actually valid, and I didn't mess up the YAML when I was copying and pasting them, which is easy to do, as we know.
Yeah.
And then maybe we'll do something more interesting with them. And what about these expectations?
Yeah, so expect error to be nil. So if error not nil,
Yeah.
how can it be more simple than if error not nil? Anyway, and then it expects the template, which is what the function returns. Can you just see what the function returns? The open.
Yeah. No, I can't.
Oh,
GoPLS isn't playing today. But
okay.
it returns template and error. So I'm guessing maybe whatever this template type is, maybe that's a Go template.
Yeah, probably the YAML in a Go template.
Or it could be anything actually, couldn't it? It could be a slice of byte. Can we click through? No, we can't. So, alright, we'll just have to shelve that question. But as you say, we're expecting the error to be nil. And as you say, a simple if statement is a lot more familiar to most gophers. And, you know, I see a lot of people who are new to Go and they say, it's really annoying for me to have to write if error not equals nil, return error or something after every function call. So they end up writing little helper functions like, you know, call this function and return if error is not nil or something. And so now all their code just has this line everywhere. And not sure that's a dramatic improvement. But again, I can understand the motivation.
Yeah.
And also the template itself should not be nil. So I think this expect should not be nil and things like this. I think this is coming from GoMega, which is a bunch of matching functions. So we could say expect some value, and then it has a .to method on it, and we can pass to that something like be nil. It kind of reads in an English-like way, which is neat. You know, I can recognize that this is cleverly done, while at the same time not thinking it's a great idea to do it.
Simple is better than clever.
Yeah, that's right. What about the next bit? This looks kind of the same, doesn't it? This looks a bit more interesting. Let's see what we have.
Mm. So I think it's doing the same thing, no? It's just opening the YAML file.
Open the YAML, successfully parsed the template, fine. Now what?
It calls of get all serverless functions resource from the template. So this
Okay,
template's basically
clearly this is not a Go template. This must be a CloudFormation template object.
yeah, or maybe a struct.
Yeah, who knows? We're a little bit in the dark here, but let's see what we can figure out.
Okay, so it returns probably a list of functions, and then it checks it has exactly 3 functions. So it expects the functions to have len of 3.
Okay.
So yeah, it matches what's saying, 3 functions.
This is what we would normally phrase as something like if len functions not equals 3, right?
Yeah. And then it just check if there is a key called code URI blah 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 blah.
So it sounds like it's a map, doesn't it, if we're looking for keys?
Yes.
That's helpful. And one of the weird thing is, you'd expect there to be a T here somewhere, so that we call T.fatal or T.error or whatever, but there's no T because we're not in a test function. So where does the test happen? I mean, when you run Go test, what's the machinery that executes this code? No one knows. It's just simply magic. And I'm, in general, pretty much of an anti-magic kind of engineer. I like to, when I was a little kid, I used to take apart everything to see how it worked, to the great delight of my parents, especially when I couldn't put them back together again. But it's got me where I am today, so,
Yeah.
But I'm the same with code, if it's not obvious how we get here or how this works, I find that awkward. And presumably there's a test function somewhere which sets up all of this.
Yeah. So.
But we don't see it.
Yeah, so it checks if all the 3 functions that's in the template is there in the functions returned by the template, whatever template is. And then it gets the first function, which is code URI with S3 location specified as string. So it should parse a code URI property with S3 location specified as a string, and then expect f1.code URI dot string to point to equal S3 test bucket test key dot zip. But where this test bucket test key is coming from?
No idea, but it starts to look as if, this pleasant seeming DSL language starts to break down, doesn't it? And I actually find this quite hard to read.
I think it's inside of the template, to be honest. I think it's a parameter for the template.
Yeah, absolutely. What I mean is just the language in which these expectations are expressed. Like, expect so-and-so to point to equal something. Like, clearly this is stretching the DSL a bit. And it probably would have been much easier to read if we'd simply said, if F1 code URI, if star F1 code URI equals this string or something. But the problem is, because we're in this Go mode, we can't really suddenly switch back to vanilla Go, can we? I mean, we can. It would just look weird. So here's another thing about DSL-based testing libraries: is once you're all in on it, basically. Once you start doing this stuff, all of your tests have to use this, no matter how convoluted or difficult it is. So
Yeah.
you'd better hope that this framework is going to do everything that you need it to do. Even though it would make sense to just use normal Go for parts of it, that would be even worse. Mixing the two styles would be terrible.
Yeah.
You wouldn't want to do that.
Yeah. And I'm trying to understand what point to do, because, you know, it's a string. So why do you need a point to and not just equal if it's string?
Yeah, if I remember rightly, practically everything in AWS is a pointer to something, and instead of just being a pointer to string, it'll be a pointer to some kind of type called AWS string or something like this. So that makes it even more fun.
Yeah, if you look, the bucket or the key or the version is not like that.
Yeah.
Yeah, that's weird, man.
Yeah. Oh.
Anyways, yeah, that should be the API specification or something like that.
Yeah, okay.
I have no idea.
All right, that's cool.
So it does the same thing for all the three functions. And the third function, it's basically a folder, I think.
Yeah, sounds reasonable. Bukola joined us. Hello.
Hello.
So we're just working our way through some of this test code in the AWS client. And we're talking about this interesting test framework. Have you ever seen any code like this before?
No, I was going to ask in the chat, like, what am I looking at? Like, is this your own framework or something?
Exactly, and this is, you know, essentially people come to Go from different directions. You know, some come from a Ruby world or a Java world or a Python world or whatever, and those languages tend to have their own popular testing frameworks, their own ways of expressing test cases and things. And people like to have something comforting. You know, when they're in a new and scary language, they like to have a comforting thing with them. Hey, at least the tests look the same, right? You know, so I think that's the motivation for using libraries like this. And Testify is another example. Have you come across Testify?
Yeah.
So that's, yeah.
But I haven't used it.
So that's from my esteemed friend Matt Ryer. He founded that one, and that I haven't actually used it, but it's an assert style, what I would call an assert style test framework, where, you know, if you have ordinary Go tests, like just using the built-in testing library, you tend to have things like call the function if not equals nil, you know, t.fatal or something like that, don't you? And this is straightforward to most Gophers who've written a couple of tests. But with Testify, you can write things like assert assert not nil, something like that, right?
Oh, is that Testify? I don't know why I don't think of it as Testify. I think of UStart. Is it a framework or a library? I thought it was a library.
Well,
like an assertion library, isn't it?
Yeah, I mean, I suppose framework is just a term we use for a library that's got a high opinion of itself. You know, and I think it's a useful distinction, because a framework, I would say, you know, with a library, you're doing what you want to do and you're using bits from the library to help you. Whereas with a framework, you're doing what it wants, right? Like here, for example, we don't actually have any test function. So there's no func test something something. There's no t object. So somehow this code will be called by magic when you run go test, presumably, and it's the magic that I'm not keen on.
Me neither.
And you know, if you use testify or something and you're using this assert style of things, what you tend to do is you tend to have a lot of assert something. So you do something and then you say, assert there's no error, assert that we got something non-nil as the value, assert something about it, assert that it's not an empty string, you know, assert that it's a pointer and it's not a nil pointer, and this kind of thing. And that's fine, but again, it rather boxes you into this one way of doing it. Like here, there are some complicated bits of logic where maybe we would prefer to just drop into ordinary Go, but it would look a bit weird because we're in this very specific kind of framework. And what I see a lot of testify users who are kind of writing code like, do this thing and then assert 72 things about the results. Makes for really boring tests. You know, not that we need tests to be exciting to read, but I guess what I'm saying is, if you want to verify one or two things about what's happened, you can do that perfectly well without assertions. If you want to check each one of 72 different properties, you're probably much better off just creating the exact object that you expect to get and then say, is it the same as what I got? You know, if you get a struct with 72 fields on, just create the struct you want and then say, if want equals got,
Yeah.
We wouldn't write down for each field, you know, if got.a equals want.a, if got.b equals want.b, but that's what we're doing with the asserts.
Yeah. Yeah. Yeah, I tend to do that as well. Is that bad?
Well, I think it's definitely a matter of taste, this stuff. And even though I kind of come from that Ruby RSpec style world, it doesn't suit my taste. Perhaps, you know, I've been doing Go for too long and I've gone native. But I like writing if not equals nil. You know, so I think there are some super useful things in Testify, by the way, and I'm not dumping on it by any means. It's got some really powerful ways of matching certain things. You know, so for expressing your expectations about values and things, there's some really handy shortcuts, which otherwise you would just have to write yourself as test helpers, and you know, we don't need to do that because they've been done in this really widely used library. However, what I would say is, you know, Tiago and I were discussing earlier how when you're new to Go, you look at Go code and it looks weird and alien to you, right? Perhaps you've had this experience.
Yeah, that was my first reaction as well when I saw it.
Yeah, so you think, well, I don't want to write code like that. I want to write code in a familiar way. So you do that, but of course to people who know Go, your code looks weird and alien. They say, what are you doing? That's not Go-like.
Not idiomatic.
Yeah, exactly. And the idiomatic is just a fancy way of saying it looks weird. Or non-idiomatic. So, you know, I think sometimes people reach for Testify and say, this looks like RSpec, you know, I know this. I'll use that. And they never actually learn how to do it the Go way, which I think is a shame.
Fair enough.
I think it's definitely worth knowing the standard way to do it, if you like. That's not to say that the standard way is the best way, of course, but it's the standard way. And there's a big advantage in that. It means anyone who knows Go can come and look at your code and they can make sense of it. So my advice would probably be, if anyone was asking it, is to say, you know, learn how to do all your testing using Go's built-in standard testing library. And only then start looking further afield to say, are there third-party libraries which let me do useful things in tests, like make assertions if I want to do that, or write this kind of DSL of, you know, it should do this, it should not be nil. and things like that. It's useful to have all of these tools in our toolbox, isn't it?
Yeah, definitely.
I would never say to someone, you know, only ever do it this way. Never, ever, ever do this other thing. Because there are always situations where that's a better idea. But if you only know one tool, that's the one you're always going to use, isn't it?
Yeah.
If you have a hammer,
Looks like a nail.
yeah, exactly. Okay, so that's my rant about testing frameworks in Go. So, did you want to ask anything about this before we move on to the next bit?
Yeah, I mean, you've explained it, like you've given me a good intro. It's a framework, so which makes sense because if I didn't know this was a Go code club, I would wonder at first, without seeing the files,
Yeah.
what I was looking at.
Right. Yeah, where's the Go you promised? But we can understand this stuff. So, like, you know, Tiago wasn't familiar with this Ginkgo library or even this way of expressing tests, but, you know, he's able to look at it and figure out what it's supposed to be doing. So it does the job in that sense. Just looks a bit weird and alien to my eyes. So let's look at another part of this. So the context here, by the way, is that this is a client for AWS Serverless. So if you want to deploy, I don't know if you've written any serverless functions, have you?
Yeah, but I've never used this SAM framework. I just write Fuel.
Okay, well you know
CDK or CloudFormation, just write mine. Yeah.
Right, you know much more about it than I do then, because I haven't, so you can maybe help me. So the AWS SAM Local Project is designed to let you test your serverless functions locally. So I think they run a Docker container, you know, to give you the exact same environment that you have in SAM. And
which is not very complicated. We have a project called Minio, which is an S3 compatible object storage.
right.
So like everything that you do in AWS, you can use Minio, even the same CLI.
Nice. Okay. So, all right then, Bukola, perhaps you would like to start us off by just trying to read what the code says, and we'll try and figure out between us what it's doing, okay?
Okay. Events. What events have we got? So I'm suspecting, so events, we've got a map, string key value, S3, SNS, Kinesis, Dynamo, API. Is that API gateway, maybe?
Yeah, these look like different types of AWS services, don't they? And one of the verbs that we have from the CLI tool is to generate events. Presumably because these events could trigger your cloud function.
Yeah.
I mean, yeah. Okay, good. If that
like,
makes
sources, like the Lambda sources trigger.
Right, if that makes sense to you, then I'm probably not going wildly off base, which is comforting. So we are effectively going to be using a bunch of template files to generate, I'm guessing it's YAML, isn't it, probably? We're going to generate a bunch of YAML here. Oh, JSON, actually, yeah. So it's going to be all of this stuff, and we're going to be interpolating a few things into this, so that's end of spoilers. Let's so these variables, S3 event and so forth, these are these raw strings, these massive raw strings. I think I probably would have put these in files, don't you think?
Yeah.
So this is very similar what Terraform does in the tests. They use like that. They use a string in a variable, and they send this in the function. I
Yeah.
don't know why they don't use files too, but it's now I'm thinking that's very similar on what Terraform is.
Yeah, well, of course, you tend to have this problem in Go that if you want to, say you have some JSON file or a template or something that you want to use, or even HTML template, you can put it in a file, but then you have to ship that file with your binary, don't you? So that's a
Yeah.
pain, because if you run the binary and it says, okay, open file so-and-so.json, well, that file isn't there, or it will need to be there. So now you have to ship a bunch of files and dependencies along with your binary. You may as well be using Python. And I don't mean that as an insult by any means. But
I'm
if you're
taking
going,
personal.
yeah, if you're going to have to deploy a big package of assets, then you've already lost some of the nice things about using Go. So ideally, we would like to compile everything into the binary, and of course, this is one way of doing that: is just make it a raw string within your program. There are other ways, such as using Go bin and other things, and I think there's now a proposal for an official standard way of encoding assets into your Go program. I don't know what it is, but you can go look it up. So that's perhaps why they're doing that. Okay, what's next? So what about this generate func?
So I imagine that's meant to generate the event. So it takes an event type.
Yeah, would that be one of these keys, presumably?
Most likely. Yeah, it seems. It seems so. Another sample, yeah.
What about the CLI context thing?
Yeah, the CLI context. No idea what that means, actually.
So we're importing yet another CLI framework. And we talk about these a lot on Code Club because, you know, most everybody writes CLIs in Go, and despite the fact that Go has perfectly good support for these in the standard library, people like to use frameworks, and often we end up writing more code than we would have done without the framework, I think, which is, you know.
But I suppose it also depends on what framework, what problem the framework solves. Is it worth spending the time to write, you know, write the tool or the functionality itself? I mean, I don't know. So I wonder what the reasoning behind this decision was.
Yeah, well, I mean, if you think about the evolution of a CLI, I mean, the simplest thing you could have is just a main.go. You just run it, no arguments, no parameters, no flags. It just does whatever it does. That's easy to write. You just write func main. That's it. Suppose you want to take some arguments on the command line. That's all right too. You can look at os.args. You'll get your command line arguments as a slice. You can see how many there are, and you can validate them and so forth.
You can use flags, right?
Yeah, absolutely. So next thing is like, I want to add some extra switches or flags to control behavior. So you can use the flag library for this. And then you start to get into, you know, more complex CLIs where maybe you have verbs, you know. So like if you think about something like kubectl, obviously that's the it's the ultimate CLI nightmare with a million different verbs, each of which takes different sets of arguments and different sets of flags, and the meaning of the flags is different depending on the verb that you're invoking, and so on and so forth. Now, if you're writing that kind of tool in Go, you're definitely going to want something like Cobra, which I think is what kubectl uses.
What's Cobra?
It's a sort of a mega framework, you know, which can do that kind of thing. And what you do is you define your different verbs and stuff. So like you could imagine create, read, update, delete, that kind of thing. And again, it has lots of magic behind the scenes, which makes it all work, and it's great, but you definitely don't want to pull in all of that Cobra complexity just for a simple tool.
I agree. Yeah.
So I think, so this is maybe the reasoning, isn't it, that people think, oh, I don't know how to do CLIs in Go, so I'm just going to Google for something like Golang CLI framework. You come to Cobra or one of these, and you think, great, apparently that's the thing. You know, it might never occur to some people, hey, maybe you don't need a framework at all. Maybe you can just use the standard library.
I think I'm the opposite a lot of times. I'm always tempted to like write it myself, and then reach out when I feel like, you know, I'm needing a bit more help than what I can do myself. So
yeah, me too. You know, ultimately, I'd rather debug my own terrible code than somebody else's terrible code. And that's what it usually comes down to, isn't it?
True.
So, okay, so we don't know exactly what the Code Gangster CLI is, but sounds pretty fly. So what's interesting is that we don't return anything, do we?
No. Does something.
What's that about?
We've got a switch statement there.
Hey, I'm glad you joined to help me because I was having a hard time to interpret this code.
It's, as usual on Code Club, you know, this is not a tutorial, we're not holding up this code as an example of how you should write stuff in Go. It's just random code that I grabbed from the wild that looks interesting. And I'm also not saying it's terrible and you should never do this. You can make up your own mind, basically. But it certainly looks as if, well, we're going to be printing stuff to standard out, aren't we? Because we can hardly generate. Since we don't return anything, whatever we generate is going to have to get printed out. And I think we'll see that, but let's...
Or written somewhere, I suppose.
Yeah.
Maybe.
That's right. So we could imagine if we took an IO writer as a parameter, we could write to that. Certainly make testing easier, wouldn't it, Tiago?
Yeah. Yeah.
For sure.
So what about this bit? So what do we think is happening here?
It's just getting the value from the map events from the event being sent or whatever called the function.
Yeah, have we seen this? Have we all seen this kind of syntax with maps where you receive a value and OK? And OK tells us, yeah, it was in fact in the map, because if it's not in the map, you'll still get something. You'll get the 0 value of whatever the type of the map value is. So if it's, in this case, it's string, isn't it? So we'll just get an empty string if event type was not in fact in the map. But sometimes that's fine, and sometimes we actually care, no, I need to bail out if that was an invalid key.
And as an aside, I found one of the articles helpful today. Saved me a lot of time not to write tests.
Oh, that's great.
Order of items in a map.
Ah, yes. That's a nice
so
one,
that saved me a lot of time.
That's really cool. Yeah, I was talking to one of my mentees about this the other day, and we were saying, I reckon I could definitely write a blog post of like 10 things which will bite everybody in Go. Sometimes, even if you know about them already, they'll still bite you. Maps will definitely do this kind of thing. Getting the 0 value from maps. Tons of things to do with concurrency will hurt you at some point. And map ordering is definitely one of those, isn't it?
Yeah.
I believe the spec says something like the order of iteration of map keys is not defined. And it used to just be effectively random, because when you insert new keys into the map, it goes into one of the map's hash buckets, and maybe it creates a new hash bucket or whatever. So when you enumerate that map, you just walk over those hash buckets, and it's kind of random, or maybe it's the order that you inserted things, or maybe not. And it turned out people were relying on this order. So, in fact, what they did was deliberately randomize it, so that every time you run your program, your map will in fact have a different order.
It's an interesting one.
Yeah, that's one way to fix that issue, isn't it? It's just, maybe it's confused people even more. But now, just to make it extra fun, is when you print out that map, guess what? It'll always print in order.
I haven't noticed that. I will try that.
So, yeah, I mean, this is, makes it extra interesting, because programs will say, well, when I print my map, it's in the order that I expected, but then when I iterate over it, it's not in that order, so what's the deal? And I think the rationale is basically, for testing or whatever, it makes sense to always print them out in that order. But it does confuse a lot of people, including me, every time I forget this and wonder why it's not doing what I expected. So, okay, that's very good. So, Tiago, would you like to pick up at this point, and we'll see what happens next?
Sure. So it's calling the template.
Now this is a Go template, isn't it?
Yeah, because it's calling template.new.
Yeah, so are we familiar with this library? Have we used it?
No, I haven't.
Templates is one of those weird things in Go that it's quite a big thing. There's a lot of functionality in the standard library around it, but it's quite rarely used. I've used templates once or twice. And it does what you think it does, in the sense that if you give it a string like this, you can insert some of your own data into it, like using this syntax, so double curly braces, and you can actually do more than just insert data items, like with functs printf. You can even do logic, and you can do little loops, and you can do if statements and things. But the template language is not Go. It's its own language. It's a DSL, if you like. So that's another little language you've got to learn.
Is it kind of Jinja template for Python?
Similar to that, yeah, same idea. Although I think
is it part of the... Sorry.
Go ahead.
Is it part of the standard library, or...?
Yes, it is, yeah.
Okay.
So, yeah, I think in Jinja that the templating language is actually Python, isn't it? You can just write valid Python inside these delimiters, whereas with Go, it's not. This is not Go, because we've got this weird dot character.
It's just got its own syntax.
That's right, which is a bit weird, and not everybody loves this. But to be honest, the 90% case is just I have a string of JSON, and I want to insert some values into it, and this works pretty well. And you can imagine for web apps, perhaps you want to have your HTML pages as templates, and you just want to insert the person's name into it, or whatever, rather than deep in your code printing out lots of little snippets of HTML in amongst your code. What that lets you do is just put the whole web page into a template and then insert stuff into it, isn't it?
Yeah.
Sorry, you were gonna ask.
Yeah, just for this use case, which is just a simple variable substitution, printf would be enough, right?
Yeah.
Okay.
Yeah, it would. And I don't see anywhere where they actually use any logic. But you know, why would you want logic? Well, one thing is maybe you might want to repeat something. So
Yeah.
you'd imagine generating an HTML table where you have one row for each
Or
record.
a condition.
Yeah, so you wouldn't have like 25 rows in your template. I mean, you wouldn't know how many there would be. So you just say loop over this slice and insert each record into a line and then repeat that line as many times as you need. So the way this works basically is you create a new template object which has some name. Doesn't matter what the name is. It's just for your benefit. And then you use parse to give it the template text. This is, takes this text and says, thank you very much, I'll create a template out of that, and then I have this template object. What can I do with it? What I can do with it is I can execute it. So T is the template that we created here, and we're saying, so when you execute a template, what you're doing is you're executing it in the context of some data, right? Does this make sense? Like you
rendering the template.
Yeah, you're saying you wanted to insert some data, so give me the data. Give me something to write to, first of all. In this case, standard out. Give me some data that I will be using to insert into the template. So we're saying here's an arbitrary anonymous struct type, which just has region, bucket, and key. I think we know what this is about. And here's the actual data. And you're going to execute this template. So this is the S3 one. Let's have a look at that. I think that's this one, isn't it? So here's our JSON, yada, 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 yada. Here's our template. So we're saying dot key. So, we're familiar with referring to Go structs. If your struct was called data, you could reference data.key and you get the value of the key field, right? This is exactly that, but there's no struct before the dot because we know that's the piece of data we were given in the execute call, right? So when we're executing this template in this context, we're saying here is this struct, and you're going to be referencing the dot key field, also dot bucket and dot region. Don't know why it's this weird dot, but it is.
What is the CLI doing? The context CLI doing here? What's its role?
Good question. Okay, so we're referring to it as C. So the thing is that what a CLI framework is basically about is grabbing stuff like command line parameters and flags, isn't it? So we've got some sense that those are going to be somewhere inside this C object, and in fact we reference them here. So I think we're saying we expect to have a string flag called region. Generally with the AWS tools, you say something like, S3 region so and so, bucket something else, key something else. So I think that's what this is doing. So by executing that template, we're effectively saying print the template to the writer I'm going to give you, standard out, interpolating these bits of data as you go. So I'm all right with that. It looks like these other cases are more or less the same. That's an interesting one. What do you think's going on here?
Just setting base 64 encoding.
So we have some data which is coming from the command line flag. We turn that into a slice of byte.
Yeah.
We call base64 library to encode that to a string. So this is common with AWS and other clouds, isn't it? That if you give them arbitrary binary data, they expect it as base 64 encoded. So it's printable, basically. You know, if you cat it to the terminal, it doesn't make your terminal go all crazy and set it into an alien character set or something. And then we exit. So that sort of explains why we didn't return anything, doesn't it? Because we're just going to be printing whatever it is to standard out. Good luck testing this, by the way.
All the nice side effects.
Yeah. Well, your tests are going to be quite verbose, aren't they? Because they're going to dump out all of these templates.
Yeah.
You can use grep after the test.
Okay. Now you have to think of all the clever ways to test. Yeah. I mean, how would you test this?
Yeah, well, what
would you be testing that output that you get on the terminal?
Yeah, well, one thing, this is a tip which I got from Matt Ryer, but I'm sure he didn't invent it.
Sorry to interrupt you, Jonah. I have to go.
Oh, I'm sorry to hear that. Yeah, we're a little over time, but I'll just finish this thought. But thanks very much for being with us.
Thank you. Bye.
Bye.
So he says, you know, if you want to test your binary, you can of course compile and execute your own program in the test, which is a bit awkward, or you can use test main, which is a special function that when you run go test, you know, you will start execution in test main if it's there, and you can do various things there. But even better than that is just to have your main function do absolutely nothing except call some other function, call it run or something, and what you do is you pass it your os.args, and you pass it os standard in and standard out. If you use standard in, you probably pass it standard out. So you're saying, here's your arguments, here's your flags, here's your writer to write to. Now it's super easy to test that, isn't it? Because you can call run from the test. You can pass it whatever arguments you want to test, and you can give it a bytes buffer or something and say, hey, write into this. Now your app thinks it's writing to the terminal, but we know secretly it's actually writing into our buffer. And then in the test you can say, okay, let's look in that buffer. Does it contain what I expect to see? So that's a really nice technique. But if you're really super smart, you would say, well, maybe I just make this function take a writer. You know, you could imagine.
Yeah, I mean, that would have been my first.
Yeah, exactly, because you're smart.
That would have been the first thing I would have done. Well, I wouldn't say so, but I don't know if that's the right thing, but I would have just reached out for like the interface and hope for the best from there.
Yeah, exactly. So whenever you have anything which generates output, it's useful to think in terms of, could I use an IO reader or writer here? And that automatically makes it testable. And if you're used to working test first and doing TDD, well, it's really hard to write a function like this without doing that, because you know, you have to write the test first, and in order to test it, you're saying, well, how do I check what it's printing out? So this is one reason why people say, you know, I wrote a bunch of code with no tests, and then I read somewhere on the internet that tests were a good thing, perhaps on Reddit, you know. And now I want to add tests to the code I have, but it's really hard because I can't test this generate function because it's just writing all over the terminal. And my answer to that is, so that's why you don't do that. You write the test first, and they say, well, I have to pass it a writer to write to. So not only is it easy to test, it's also sort of well architected, which is helpful. Okay, well, I think we'd better wrap up because we're kind of at our time, but this has been fun.
Yeah, it's been fun.
And we maybe learned something interesting.
Yeah, I've definitely learned something.
Great. Well, thanks very much for being part of it. And I hope to see you next time.
Yeah. Bye.